Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from lunchboxsessions.com, and this video will be about how a load-sensing pump can be used to keep the speed of a hydraulic motor or a hydraulic cylinder running accurately, even if there are some fluctuations in speed at the prime mover, whatever device is driving our pump shaft. Now, if this was just a basic gear pump, any increase in RPMs at the prime mover would categorically push more flow out into the system. And even if we thought we had a flow control adjusted to keep our motor running at a certain RPM, if that gear pump pushed out more flow, and of course the pressure would rise in front of this restriction, our pressure differential across our throttling device would certainly increase. And that's definitely proof that the flow through the device will increase and our motor speed would increase. But we don't want that to take place. So we're not using a basic gear pump. We're using a load sensing compensated piston pump, sometimes called a flow compensated piston pump. And we want our hydraulic motor to maintain steady speed even if the prime mover, the diesel engine, has some speed variance. Perhaps our hydraulic motor is turning an electric generator. That's an application where you want very steady RPMs of the hydraulic motor. So keep an eye on the tachometer that's monitoring our hydraulic motor, and I'll increase the RPMs of the diesel engine over here on the left. And what you should be noticing is the tachometer for the hydraulic motor isn't changing. Now I'll back the throttle down on the diesel engine, and our motor is staying nice and steady. If you're watching our special pressure gauge that has two inlet lines called a delta P gauge, a differential pressure gauge, what you'll notice is that there are some minor little bumps as the prime mover speed changes, but it very quickly returns to its nominal value after the pump controller is done responding, doing what it needs to do. So in another video of ours called What is a Load Sensing Pump, we spent a fair amount of time talking about the load sense signal that travels back to the pump controller when the resistance felt by the hydraulic motor or cylinder changes. That's a very typical thing to study about load sensing pumps. But in this case, what we're going to notice is that as we increase speed at the prime mover, that's not really affecting that load sense signal line. What that's really doing is giving us a very brief moment of increased pressure on the outlet of the pump. As that pump spins a little faster, it's as though we're trying to push more fluid against a fixed orifice, which will naturally make the pressure in this outlet line rise, but only for a brief moment. And the reason that it only happens for a brief moment is tied to what happens on the internal passage from the pump outlet over to the load sensing compensator. So watch the compensator spool and watch the control piston inside the pump as I increase RPMs on the diesel engine. Here we go. Increasing speed. Did you watch what happened on the load sensing compensator? The spool would pop up and direct control fluid into the control piston, de-stroking the pump slightly, reducing its displacement, and in so doing, very quickly restoring our desired delta P across the throttling valve, allowing our hydraulic motor to run at a very steady speed. Isn't that a clever, helpful thing for a load sensing pump to do? I hope that's been a valuable lesson. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.